Alrighty guys, we are on the final review, page 4, starting with number 18. We're going to start by multiplying and then simplifying radicals. To begin this, we are going to be distributing. Since it says multiply and it looks like distributing, that's what we're doing. I've underlined each term that we are going to be multiplying. So we have 1 on the outside times 2 on the inside. 1 times 2 is 2, so we're going to have 2 terms. Let's start by multiplying 3 root 2 times 9 root 5. We multiply outsides times outsides, so that's going to be 3 times 9 on the outside. And then on the inside of the radical, we have a 2 and a 5, so it's going to be 2 times 5. You're welcome to already multiply all of that out. I'm just showing you the steps. Okay, we have a 3 root 2 times a negative root 2. We can put the little invisible 1 in there. So we're going to be multiplying 3 times negative 1, so plus 3 times negative 1. And then inside the radicals, we have 2 and 2, so 2 times 2. Okay. First radical, 3 times 9, 27. Inside, 2 times 5 is 10. Second one, 3 times negative 1 is negative 3. Now, just like the very last problem, number 17 on the last video, we are supposed to be multiplying together everything that is on the inside. So 2 times 2, yes, is 4. Or you can think about the fact that this radical has an invisible little 2 right here, meaning that we should be underlining 2 of the same number. Okay, so we can underline 2 2's, and that means that we bring out a 2, meaning that inside the radical there's nothing left. There's nothing in there. That means that we really don't even need that radical, so we can just get rid of it. Okay, zoom back out. So we've got negative 3 times 2 over there on the right, which is negative 6. And we still have the 27 root 10. Okay. On number 16 on the previous page, we combined like radicals together. The radicals have to be the same. Our first term has a square root of 10. The second term does not even have a square root at all, so we are done. 19, we are multiplying first and then simplifying like radicals. Just like on 18, we're multiplying outside times outside, so that's 24. Inside times inside is 5 times 10 is 50. Okay, let's take that 50 and let's make a chart for it. 50 is 5 times 10. 10 is 2 times 5. Nothing else breaks down. Okay, 50 got broken down. 10 got broken down. So the numbers that we're going to put inside of the radical are 2, 5, and 5. So you have a 24 outside, and then inside 2, 5, 5, all multiplied together. Okay, I like to put those numbers in order from least to greatest, so all the 2's are next to each other, all the 5's are next to each other, and so on. Double check, does 2 times 5 times 5 actually equal 50? Double check it before you keep going. Okay, we need to simplify. And to do that, we need to know how many numbers are going to be in each group. Okay. The invisible little 2 index right there says there needs to be 2 numbers that are the same for a group. So we can make a group of 5's. So outside we've got a 24. We're going to bring out a 5 from the inside because we had one group of 5, so we write 5 one time. And then inside we still have that 2 because it could not get a group. There was only one of them. Okay, this little 2 index you can bring down if you like to see the 2. And then we clean it all up, multiply outsides times outsides. 24 times 5 is 120. Insides, all we have is a 2. If there were more things inside, we would actually multiply them together, and this is what we get. Number 20, conjugates are super quick problems. The conjugate really just means that we're going to have the exact same thing, except in the middle, instead of it being a minus, you're going to put a plus. Okay, if it was a plus, you would just make it a minus. So you flip the middle sign and you are done. For number 20, we need to start by finding the conjugate of the denominator. So this is really similar to number 20. Our denominator is 8 plus 3 root 5, so our conjugate is going to be 8 minus 3 root 5. So that should be a very quick part of the problem. The next bit of the problem, I am going to focus on just the numerator and denominator section. Bring these over here. Okay, our numerator is a 6. Our denominator is 8 plus 3 times the square root of 5. I'm going to put it in parentheses because we are going to be multiplying times that conjugate that we had up above. So the conjugate of the denominator is the 8 minus 3 times the square root of 5. If you multiply a fraction, to not actually change the fraction, you need to multiply both the numerator and the denominator times the exact same thing. So it is going to be multiplied times the 8 minus 3 root 5 that we had for the conjugate. 8 minus 3 root 5. Okay. Now this really just becomes two different multiplication problems. So let's focus on the numerator. 6 times 8 is 48. And 6 times negative 3 root 5, we do outside times outside, negative 18. And inside we have a 5, and that's the only inside of a radical that we have. Okay, so that 48 minus 18 root 5 is going to be the numerator in our final answer. 48 minus 18 root 5. Okay, focus on the denominator now. This is going to reduce a lot prettier than it looks. So it looks kind of terrible because we have 2 terms times 2 terms and we've got some square roots, but we will just get one number for our final answer on this. Let's multiply 8 times 8, 64. 8 times negative 3 root 5, outside times outside is negative 24, and keep the root 5. Okay, then 3 root 5 times 8 is positive 24 root 5, outside times outside, and keep the root 5. Last times last, we have a 3 times a negative 3 is negative 9, and then inside times inside, we have 5 times 5 is 25. Okay, at this point, we're going to combine like terms. Our two middle terms are alike because they both have a square root of 5. And we should notice that one of them is a negative 24 and the other is a positive 24. So they add up to get 0. We can just cancel them out right now. Okay, let's bring down that 64 that was already there. And then over there in yellow, I'm going to switch to black so we can see it better. We have a negative 9 times the square root of 25. Well, the square root of 25 is 5. Just means what two numbers multiplied times itself equals 25. Okay, so that is 5. Bring down our 64. Negative 9 times 5 is negative 45. And we can actually just combine these two numbers together by subtracting, and we get 19. So 19 is our denominator. Okay, so this fraction is our answer. Alrighty guys, 3 problems left here on the front. Number 22. Our goal is to get x by itself, and before we can actually do that, we need to make sure that the square root is by itself, okay? So that we can actually square both sides and not make a bigger mess. Okay, so first off, we want to get rid of that plus 3 that is on that side. So we're going to subtract 3 from both sides. Okay, these 3's cross out, and on the right side, we've got a 9. Left side, we still have square root of 5x plus 6. To get rid of a square root, we are going to square both sides. Okay, we're picking a 2 for our exponent because, like we talked about before, if a radical does not have a number here, it's an invisible 2. Okay, so we just match that same exact number. If that radical was a 3, we would cube both sides, meaning put it to the 3rd power. Okay, left side, square and square root cancel, so we've got 5x plus 6 equals, and then on the right side, we actually do some work because there's no square root over there to cancel. 9 squared means 9 times 9, which is 81. And then here, this becomes a really familiar problem. We're going to subtract 6 on both sides, and we get 5x equals 75. Divide both sides by that 5 to get x by itself, and we get x equals 15. Done. Okay, on the previous problem, I alluded to the fact that our exponent really depends on whatever this number is. So that 3, that index or that root number, is going to tell us that we are going to cube both sides, which means take both sides to the 3rd power. On the left, cube and cube root cancel each other out, so we've got 11x minus 6. And on the right-hand side, we have 3 to the 3rd power. Okay, 3 to the third means that we have 3 3's multiplied together. 3 times 3 times 3 is 27. Then again, this becomes a really familiar two-step equation. Let's add 6 to both sides. We get 11x equals 33. And then we divide both sides by 11, and we get x equals 3. Okay, now we are matching function types to examples. We actually already did something really similar to this for linear, quadratic, and cubic on, I believe, the front of this page. Should be like problems 1 through 8, I believe. C, D, and E have to do with biggest exponents. Okay, for linear, our biggest exponent is going to be a 1. Quadratic biggest exponent is a 2. Cubic exponent 3. And then let's go back up to A and B. It says exponential. For exponential functions, that means that your exponent is an x. So we can do a lot of this work before figuring out the difference between growth and decay. All right, so let's look at C for linear. We need an exponent that is a 1. Okay, so invisible 1 for our exponent. Looks like we have number 24 for that. So number 24, invisible exponent of 1, so that is letter C. Quadratic is the biggest exponent of 2. The biggest exponent of 2 is found on number 28, so 2D for 28. Cubic, biggest exponent 3, happens on number 26, so 26 is E. And then we just have to figure out the difference for A and B for exponential growth and decay. And double check at this point, the exponents are the x's. Okay, so let's look on number 25 a little bit closer. 25, the base for that exponent of x is a 0.7. And on 27, the base for the x is a 6. Okay, growth versus decay happens because our numbers for the base are either bigger than 1 or less than 1. Bigger than 1 makes your problem bigger. So 0.7 is less than 1. 6 is bigger than 1. So it looks like that 6 for number 27 is going to get us numbers that get bigger and bigger and bigger. Okay, so 27 is going to be our growth, so that is A. 25, the 0.7 was less than 1. Less than 1 means our numbers are going to get smaller and smaller, which is what decay means. So 25 is B.